Welcome to Math 104, where we're talking about linear regression. This is going to be mixed with average error to a degree, and we are just going to be following along the same structure until you get a little bit more familiar with your graphing calculators. Again, I'm using ATI 84 here through the app, and then we'll be switching with we can switch over to Desmos for different videos. Okay. So first thing, we always want to make sure that our graphing calculator, if you haven't reset it in a little bit, be sure to hit the reset button by hitting second plus sign 712. If you don't want to reset it, that's okay. Just make sure all of your lists are cleared. So you can hit that by doing these buttons, making sure that your scatter plot is turned on, making sure that any y equals equations, those are all cleared. They just kind of junk up your calculator and it can be confusing at times. So let's go ahead and hit stat edit. We're going to enter in the given data. So right here, and actually I should back up, we have a problem to go through. This says the total of federal direct student loans in billions of dollars for the selected years from 2011 and projected to 2023 have listed. So we have listed these particular values, and we're going to be finding the following. It says find the linear function that models the total loan debt y in billions of dollars as a function of years after 2010. Report this with 3 significant figures. I think we've already covered significant figures. If you are in a class where we have not yet watched the sig figs, definitely go back to, that would be in chapter 2 intro, or a video that says chapter 2 sig figs, where we talk about what significant figures are and how they help us. We're also going to be talking about what the report models predict this debt to be in 2027. And part C says, when does the report model predict that the debt will be $1,389? So we're doing problems that we've encountered before or similar ones from before, and we're just putting these data now on to find an actual equation. So here we have your list. Now, because we did say that X is the number of years after 2010, if the data is giving us years and they've told us that actually, when we talk about the year 2010, X is really 0. So that means, what would 2011 X value be? Well, X would be equal to 1. And then over here, 2013 is X is equal to, not 2, but 3. So let's see if we can continue this trend and write our new values in list 1. So we said for list 1, we should have the values 1, 3. We should have 2015 as 5. 2017 as 7, 2019 as 9, 2021 as 11, and 2023 as 13. So these should be our new X values. So we always change the X values if they're a year to fit into our actual category. We do this primarily to help us out when it comes to analyzing what your y-intercept means, because it may matter in certain situations. Okay, so let's go ahead and enter in those X data along with your Y data. So let's go do that by hitting the following buttons, stat, edit, and enter in these values into list 1 and 2. So we have stat, edit. So we said we're going from values 1, 3, 5, 7, 9, 11, and 13. double checking that everything looks good before continuing. And we have 702, 940, 1220. All right. So here we have all of our list 1 and 2 values. Again, double check real quick that everything looks correct. All right, so now that we've gotten everything in your list, let's go ahead and make sure your scatter plot is turned on. I'm just going to go back to a cleared screen by hitting second mode, second y equals. Notice mine is off, so I'm going to have to flip it on. And I just want to double check that nothing is in the way when I'm looking at y equals. And I'm just going to go ahead and hit graph and nothing appears. Now, why is that? My scatter plot is on, which means if I'm still not seeing it, it's my window that needs adjusting. So looking back at my window, let's come up with values that are good for this particular graph. So your X minimum, right? Looking at your list 1, we're starting at 1 and going up to 13. So definitely getting 1 and 13 in the fold. So your X values go from 1 to 13. So which means maybe instead of starting at 1 or at 0, maybe you get a little bit more negative in order to find that space. So maybe we look at -2, X max. Maybe we go to 18. We definitely want to make sure 1 and 13 are found within that value. Your X scale, because these values, there's not much different, we can just do a 1. If you wanted to go up by 2, so that's okay. So that's for your X's. Now let's take a look at your Y's. Your Y's go from 702 all the way up to the highest one. Oops. 2,250. So your Y minimum, perhaps we go something, if you wanted to start at 0, that's okay. You can also start perhaps around 500, 600. Let's do 6. Well, depends on how much we want to go up by. Let's say 400. Your Y minimum or your Y maximum. Let's go all the way up to 350. Go. Your Y scale. And again, this is up for interpretation. These are just values that I'm kind of creating based on how I'm interpreting it. So my Y scale between 400 and 3,500, I could probably be a little bit generous and go up by 150, by 200, by 250, something that might try 250, something that gives us enough of a jump to go between our values. And if that doesn't work, we can always come back and readjust. All right, so we said 2. I already forgot what my max was. 18? That's okay. I think we said what, 400? 250. Let's give it a graph. There you go. So not a bad graph. If you wanted to get a little bit lower into the negative Y's, that's okay. But my main concern is to make sure that all of my data points are all accounted for. So we should have 7 in total. 1, 2, 3, 4, 5, 6, 7. There we go. All right, so we see our graph. We now have to determine, is it a line, a quadratic, a cubic, quartic, so in those types of things. So what do you guys think these data values look like? To me, they're going to look like a line. So we're going to talk about your linear regression to start. So once you determine what your graph looks like, we're going to go ahead and hit Stat Calc. this is where we get to choose specifically lin reg. We did this before with average error. So when we go to look at your lin reg, we want to make sure that we're also storing your equation. We don't want to have to enter this long equation that you might be seeing here soon by hitting vars, y bars function, and y1. So let's go ahead and hit just a cleared screen. So just by hitting second mode, that's kind of like where I like to start. So hitting stat, calc from above, and going all the way down to number 4, where it says lin reg ax plus b. Now there are 2 lin regs on some calculators. It's just switching. So sometimes it has a plus xb. That's not the one we need. We just want it a very regular term. So it just confirms your x values are in list 1, your y values are in list 2, and then it says store reg eq. Now, if your calculators don't have this, maybe you're working off of an 83, you're going to hit the same exact buttons with us. Okay, you're going to hit vars, y bars, function, y1, and this is where we're going to store it. If you don't have this screen, if you're working with the TI-83, it should just say lin reg and then y1. That's perfectly fine. Go ahead and hit enter, and it pulls up this whole thing. Now, if yours doesn't pull up r or r squared, please go back to the video where we talked about average error, and it brought in how to find your correlation coefficient, that r in r squared. So now we have this long equation. It does say 3 significant figures. This is going to go off of the knowledge that perhaps we have already watched significant figures, that lecture video. So 3 sig figs. Did one, let's see. Actually, we're going to switch this. Instead of 3 significant figures on this first one, let's just round to 3 decimal places. That just changes it up just ever so. Yeah, let's just do 3 decimal places. So right here we have y equals ax plus b, and we have 3 digits, or 3 counting 3 decimal places. I'll show you at the end of this video what it's going to look like with 3 significant figures and how that makes a big difference. All right, so we have our values right here. Hopefully I can remember what they are. Nope, I already know I'm not going to remember. Okay. Just did that really quick. So now when we record, normally it's y equals ax plus b. This is modeled after a linear equation. Think about mx plus b. That's the same exact one. So we have 30.696 is your A. B we said was 568.982. So putting these together, we should have y equals 130 plus 0.696. That's a terrible spot to put this. Y equals 130.696x plus 568.982. Okay, so this is your equation written out with 3 decimal places. Again, at the end of this video, we'll talk again about how it's going to look differently with 3 significant figures and kind of walking you through that one more time. So this is our written equation. Now let's see what we're going to do when it comes to your R, your correlation coefficient. We said back in the previous video, correlation coefficient R determines if we have a really strong correlation between your line and your data values. We said the closer this number is to 1 or -1 determines how well your line fits. -1 and 1 being the most perfect fit. So it fits exactly right. So if we round this value to 4 decimal places, we should get 0.9995. Now, is this a really, really strong fit? Is this really close to 1 or -1 if it's trending downwards? This should be really close. So if it's a almost perfect fit, what do you expect to see? So this is nearly exact. Well, if it's nearly exact, when we go to see the scatter plot, because again, you've already stored your equation. This whole thing is in there. When we go to store it, when we hit graph, it should be just about perfect. Notice that in that second one, it's not quite going through the center. Same thing with the last two. They're not all through the center, but they are hitting them. They're getting through the values or through the what shapes are these? Through the squares. It's just not perfect, but is very strong. So this would be a nearly perfect fit or an excellent fit. Okay. So we said we found a function. Now let's go ahead, and now that we've determined this is a really good model, we can figure out if these we can predict from these. So B says, what does a report model predict this debt to be in 2027? Well, we said your X values start in 2010, right? So in 2010, that's going to be, that's when X is equal to 0. So then what is your X value for the year 2027? Well, X being 2027, or sorry, the year being 2027, X should be 17. So on your next page, it does ask you this right here, 2027. When X is equal to, what do I keep? When X is 17, that's the year 2027. And now we want to find your Y values. So go ahead and pause the video. We've done this very similar equation or very similar problem before where we have an X and we need to find your Y. So hopefully we are now unpausing. We're going to be going to second trace and value. This is anytime we have your X value and we need to find your Y value. So going to second trace, your value button here, we're typing in 17 after the year 2027. And you'll notice right on the bottom value, it says Y equals 2,790.8. So if we need to round, we're talking about money, so rounding it to 2 decimal places. So your Y value, we'll put that right here. We said 2,790.82 dollars. So based on this model, in the year 2027, we will have a debt of $2,790.82. Now, when does this report model predict that the debt will be $1,389? So Y is now given, and we need your X value. So go ahead and pause the video. We've done this one so many times, just now a different process of getting there. Well, if we have an equation in Y1, this can be our equation for Y2. So Y2, right here, we have 1,389. Let's go ahead and hit graph. We do see that intersection. We're going to hit second trace, looking for your intersect. Watch this click.
New lyrics. Nationwide helps financial professionals identify their clients long.
Okay, left bound, we want to get to the left of that intersection and to the right of the intersection. And then below it, we see that X is equal to 7 during the when Y is 1,389. Oh, so sorry. I should be looking at the very top. So your intersection in that purple one. So X is equal to 6.27, which you can round to 7 no matter what. They've just done that for us. So we can say X 6.27. So you're on your 6th year, working on your 7th year. So are we in the year 7? No, we want to add this to 2010. So this is the year 2017. And again, just kind of some of those buttons that we're hitting. We're hitting second, trace, intersect. Or if you're using Desmos, you can use Desmos once you get your equation as well. And again, we'll go back to the significant figures here in a moment. You can also try out the app Scientific Tools in your graphing calculator as well. All right, so now let's go ahead and finish this out to find your average error. So average error, we said we have your X values and your Y values in list 1 and 2. And now in list 3, we're going to multiply those Y values that are located in your graphing calculator multiplied by list 1. We're going to do this by hitting the following buttons that I'm going to be highlighting here. So stat, edit, going to go all the way up to list 3. We're going to make sure that we go over to vars, y vars function, grab y1 and multiply it to list 1. And you'll notice that your values, because it was a nearly perfect line, these values found in list 3 are going to be very similar to those that are found in list 2. Okay, now we are going to go over to list 4. There are little tidbits. If you do print out your notes, making sure like, hey, don't forget to store it in Y1. What are we doing here? Why does it make a difference? So it gives us little tidbits. All right, in list 4, we're going to subtract list 3 from list 2 to grab those errors. We're going to be doing that by hitting the following buttons. If you haven't watched the average error video, definitely go back and watch that first. So list 4, making sure we're going up there. Second 3 minus second 2. They're taking the predicted X value from your line and we're subtracting it by your actual values found in list 2. And then this is by how much we're missing. You'll notice that some are small, some are large. We didn't have an exact fit, so that's okay. And now we're going to hit second mode, kind of come out of that and see in our next one. So you said, hey, we're not going to be using list 5. Instead, we are going to hit these following buttons, making sure that we change list 4. That is absolutely key. I'm going to highlight it here because it is so important. Change to list 4. Okay, so going over to stat calc, one variable statistic, we're going to make sure that this is now changed to list 4. Second 4. And you'll notice that it comes up with this whole mess of material. And we said, hey, of all of this stuff, we really just need one particular value. We said, hey, we really need the sigma x, the lowercase sigma x, so the 16.778 value. So let's go ahead and round that to 2 decimal places. And that will be our answer, 16. What do we say, 78. So this is the amount of errors. This is how much the total amount of units that we have missed our data by. So again, this is a really good one because your graph has fit really, really well with this data. It wasn't perfect. Your error is actually pretty low. It might not seem like it, but based on your correlation coefficient, your R being really close to 1, the small 16 value also being a small margin of error shows that this is a really, really good fit. Now, let's come back to the significant figures. So before, in this page, we said, hey, this is if we are to round to 3 decimal places. Decimal places are different than sig figs. Again, if you haven't seen the lecture on significant figures, please go back and locate it. Now in this one, when we're talking about 3 sig figs, we said significant figures matter when anytime you have numbers that are non-zero. So numbers that are non-zero count. And then that's when, so like 1 all the way through 9, these are all considered significant. So when we're talking about zeros though, they change the rules. So particular zeros count. Zeros count if they are sandwiched between numbers like 2002. So they are sandwiched. Or if they terminate. So things like 0.50, right? This one counts because it terminates. This one at the very front does not. Does not count if the number starts at 0. So again, we said we could change it. 50. These numbers are starting with zeros. They don't count, but the very last one does. So that's kind of that, like in a nutshell. If you had something that's kind of a mix of it, 2002.050, they're all considered significant. So in this case, you would have 1, 2, 3, 4, 5, 6, 7 significant figures. Here you would just have 2, 2, 1, 2, 3, 4 on this one. So they change the value of the number. So that being said, if we're looking at the number, let's see, we had, what was our number to begin with? 696. When we're talking about 3 significant figures, again, the first numbers, if they're actual numbers, they're going to count. So this counts, 1, 2, they count. And when we go to look at the third significant figure, right, this one counts the way that it's sandwiched right here. But the second you take it away, that decimal place from that 6, it no longer counts. So in order for it to count to 3 significant figures, because right now this is counting only as 2, 1, 2, because then it terminates. We need it to either sandwich or there's no decimal place to the left of it. Is that the right direction? To the right of it? If we put a decimal place in here, then it will count as being significant. So the location, I should say, the location of the decimal place really matters. So 3 sig figs for 130, that number, period X. So that is 3 significant figures. Now let's try it again on your next one where we have 568,982. 568,982. 568,982. Try to get 3 significant figures here. This one should be a lot easier because all sig figs count if they're actual numbers, not 0. So it's 5, 6, 8. All 3 count. So really this one is the biggest hang up as far as significant figures. I try not to put too many sig figs in your homework. We're kind of transitioning away from that. There you have it, 3 significant figures. Oh, and I'm so sorry, I messed up on that one. When we go to do your significant figures, we also want to look at rounding. So looking at the one to the left does determine if we round up or down. So 8 will round up to 9, and that will still count as a significant figure. My apologies. I'm doing too many things at once. All right, so there you have your significant figures. Very different from rounding to 3 decimal places.